Hey learners, welcome back to another session here. A quick explanation of Newton's three laws of motion and law of gravitation. Newton's laws of motion are a set of three fundamental principles that describe the behavior of objects in motion. Here is a brief summary of each law. Newton's first law of motion states that an object at rest will remain at rest, and an object in motion will continue in motion with a constant velocity, unless acted upon by an external force. For example, a book on a table will remain stationary until someone picks it up and moves it. Newton's second law of motion states that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. This means that the more force applied to an object, the greater its acceleration will be, and the more massive an object is, the less it will accelerate. For example, a small car will accelerate faster than a large truck when the same amount of force is applied to both. Newton's third law of motion states that for every action, there is an equal and opposite reaction. This means that when one object exerts a force on another object, the second object exerts an equal and opposite force back on the first object. For example, when you jump off a diving board, your feet push down on the board and the board pushes up on your feet, propelling you into the air. These laws have many practical applications in our daily lives. For instance, the first law explains why objects stay in place unless acted upon by an external force, such as why a ball will remain still until someone kicks it. The second law is used to calculate the force required to move an object, such as how much force is needed to lift a heavy box. The third law is used to explain how rockets work, as the force of the rocket's exhaust propels the rocket forward, while the rocket's mass pushes back against the exhaust with an equal and opposite force. Now it's time to learn Newton's law of gravitation. Newton's law of gravitation is a fundamental principle that describes the force of attraction between any two objects in the universe. The concept of gravitation was first put forth by Sir Isaac Newton in 1665, when he observed an apple falling from a tree and realized that all bodies are attracted towards the center of the earth. This concept played a major role in the initiating birth of stars, controlling the entire structure of the universe. At present, this concept has significant applications in the advancement of physics. Newton's law of universal gravitation states that any particle of matter in the universe attracts another one, with a force varying directly as the product of the masses and inversely as the square of the distance between them. Consider two bodies A and B of mass m1 and m2, separated by a distance r, such that the force of attraction acting on them are represented as shown in the figure below. Newton's law of gravitation. In the figure, the two bodies having forces of attraction, F1 and F2, have a tendency to move towards the center of gravity, such that F1 equals sign F2. Therefore, the universal law of gravitation formula is given by Fr2m1m2 or Fhr2m1m2. Here, g is called the universal gravitational constant, a scalar quantity. The value of g remains constant throughout the universe and is independent of the nature and size of the bodies. When m1 equals sign m2 equals sign 1 and r equals sign 1, then from the above equation, F equals sign g. It says that the magnitude of the attractive force F is equal to g, multiplied by the product of the masses and divided by the square of the distance between them. Newton's law of gravitation holds good for objects lying at very large distances and at short distances as well. It fails when the distance between the two bodies is less than 10·9 m. There are various applications where Newton's law, two of them are discussed below. Predictions about the orbits and time period of the modern artificial satellites. The law of gravitation is used to calculate the force of attraction between the Earth and the satellite. This helps in predicting the orbits and time period of the modern artificial satellites. The predictions made on the basis of this law proved to be very accurate. Prediction about solar and lunar eclipses. The law of gravitation is used to predict the occurrence of solar and lunar eclipses. The prediction made on the basis of this law came out to be very true. The gravitational force of Earth ties the terrestrial objects to the Earth. This law explains the attractive force between any two objects having a mass. The formation of tides in the ocean is due to the force of attraction between the moon and ocean water. I hope this helps. Let me know if you have any other questions.